So you have seen the velocity, acceleration, what is that? No. What is the velocity? The rate of change of displacement is called velocity. Now let us see here. Velocity we got, acceleration we got. Now we write velocity only completed, speed completed. Next I am going to write velocity gradient. Velocity gradient. Velocity gradient. Symbol is dv by dx. dv by dx. Velocity gradient dv by dx. So change, that means what? Change in velocity by distance or displacement. The following change in velocity by distance or displacement. I can say distance or displacement, ds. Displacement. So what is the velocity? Change in velocity L to the power of minus 1. Displacement is L, cancel. So the formula is p to the power of minus 1. P to the power of minus 1. So this is the dm of what we call to say dv by dx, velocity gradient. Okay. Now unit writing. Unit is unit second inverse r per second in all systems. In all measuring systems. All measuring systems. But if no, very very important, no. So we should not write frequency. That is how frequency in hertz. So we should not write. But what is the frequency? Hertz. Frequency unit. Why? Because it is not coming to and fro. Once the velocity starts, the particle moves away from the starting point. But whereas in case of the frequency, or you can say oscillation, so the body always moving to and fro motion. Meaning it is always coming to the mean position. So this is the pendulum, the bar, so it's going to move to and fro. It is always coming to the mean position. Always coming to the mean position. Which one? Oscillation. But whereas in case of velocity, it would come to the mean position. That's why we should not write hertz, because this is not, the particle is not coming to the mean position. It never comes to the mean position. Once the body starts velocity going only, it will never come back. That's why you should not write hertz. So but we can write per second or second inverse. Our unit is, or they call unit, and dimension one is t to the power of minus 1. Right? Now go to the next. Understood? Then the velocity gradient. Next write aerial velocity. Next you can write aerial velocity. The name itself is there, aerial velocity. So write aerial velocity. So aerial velocity. What do you say aerial velocity? When area is changing with respect to time is called aerial velocity. Right? Aerial velocity. Aerial velocity. So daily we are saying, but we don't know. So that is dA by dt. So that will change, right? Changing area by time. Change in area by time. But daily we are saying, but we don't know. Change in area by time. So change in area is what? L square by time is t. So therefore, EMF of aerial velocity is equal to m to the power of 0 L square to the power of minus 1. So unit, right, basic unit only, unit. So centimeter square, second raised to minus 1 or centimeter square per second. Because which is system CGS. In MK system, kg square, kg square of meter square, kg is mass, meter square, second raised to minus 1. Okay, or so you can write meter square per second per MKS. That's all. Now we call aerial velocity. Aerial right. Next. Next, coming to the right side. Completed? No, right. Right, go to right. Note, NOT, note. Note. NOT, note, right, please. Right. In physics, right, rate. RAT, rate definition. Right. Definition, rate. When we say rate, the rate of change of velocity, your definition. If anything is going to change with respect to, distance, or anything is going to change with respect to time. If anything is going to change with respect to time, is called rate. Is called rate. Is called rate. Anything is going to change with respect to time is called rate. All right. Example. Velocity. The velocity. What is the definition? The rate means time. Anything is going to change the rate of change of displacement. The rate of change of displacement is called velocity. So another example, speed. Speed, all right. The rate of change of distance. The rate of change of distance. The rate of change of distance. So distance by time. Distance by time is called speed. Nothing. It's called speed. Next, write power. What is the power? Power is equal to what is the power? Definition? The rate of work done. Power is the rate of work done. So that means the rate means time. So work by time is called the rate of work done is called power. So in denominator time means you can say rate. In physics, rate means time. If you go to the market, rate means money. What is the value of 1 kg? What is the rate of 1 kg tomato? So what is the rate of 1 kg dal? Rate means money. What is the rate of potato? Rate means in market money, but in case of physics, the rate means time. Okay, good. No, good. Next, right, gradient. All right, gradient. Gradient. So gradient. That is gradient. Delta x. Right, gradient. Delta. The actual symbol gradient is del operation. So we are going to get del. You are right. Definition. If anything is going to change, with respect to distance or displacement, with respect to distance or displacement is called gradient. Is called gradient. Okay. Now, take example. Velocity gradient. Right. Velocity gradient. So what is called dv by dx. Force gradient. Force gradient. Force gradient, or you can say spring constant, force gradient, or spring constant, okay, or surface tension, okay. So generally all is having what? So equal to force by length or d, force by distance or d equal to force by length. So force by length or force by distance is what? Force gradient, spring constant, surface tension. Okay, now understood all. Like this, you may have this one. Completed. We call it gradient means anything is going to change. Daily we are seeing. So we are working with some speed. So velocity by it is changing. Otherwise climbing the steps. Climbing the steps. So velocity increasing and automatically height goes on increasing. Called a gradient. So daily we are seeing, but we don't know. Once you think about it, oh, this is not that much physics are easy. That's nothing. Okay. Now we go to the next one. Completed. Like this, so many examples you can take. In denominator, you put a distance or displacement. We call it gradient. Power gradient. Power by x or d displacement. We call power gradient. Okay, now. So now you can write acceleration. Next, we go to the dimension formula acceleration. Write up dimension formula acceleration. Dimension formula of acceleration or acceleration. Next, put your number. Acceleration A. So, what is the acceleration? Acceleration is equal to velocity by the rate of change of velocity. Velocity by velocity by time. What is the rate of change of velocity? What is the velocity? L to the power of minus 1 by t. That gives you L to the power of minus 2. What the mass? Unit mass. We call it dml of particular acceleration. So, what the unit? Centimeter per second square or centimeter second raised to minus 2 CDS system. So it's called CDS meter per second square or meter second raised to minus 2. We call MKS or SI motors. So write note, note. Note, right? Note. Acceleration, right? Acceleration, comma, retardation. What do you mean by retardation? Negative acceleration, comma, deceleration. This is also negative. Deceleration comma, and the acceleration due to gravity and acceleration due to gravity within a bracket g, right, small g, right, chloride, all are having same Reynolds formula and same units. All are having same DMF and units. Okay, same Reynolds formula and units. We call other units, right? Next, you can go to write force. Force completed. Right, force. So daily we are seeing now force. What is the definition of the force? Definition of force is pull or push. Formula force F is equal to ma, mass into acceleration. So write a definition. Either pull or push is called force. Either pull or push is called force. Either pull or push is called force. Or what is that? So the force is that which try to change the position of the body. The force is that which try to change the position of the body. Which tries to change the position of the body called force. The force is that which tries to change the position of the body is called force. Then only we call the force. Okay. Now coming to force is equal to ma. Now what are we going to get? M. What is the acceleration? L to the power of minus 2. We got DMF of force. Okay. Now we have what is the unit? The basic unit is gram centimeter second raised to minus 2 or gram centimeter per second square or dyne or dyne dyne. Inside. We call it CDS system. In MKS system, kg meter second raised to minus 2 or kg meter per second square. We call it MKS. Called MKS. So in SI system, you write full name, small letter, Newton or symbol capital letter. This is the SI system. Full name you write small letters and you can show symbol. Scientist fully write small letters and symbol SN. Otherwise, show symbol is capital letter. Now, so daily we are seeing force, but another force-like application, right? Next note, tension. You like NOT note. Tension also force, like a tension. Where is the tension? You write a tension. Symbol is T. Tension symbol is T. So where you are going to be when two masses are connected with the string. These two masses are connected with string and applying the force. So this is one mass M1, another mass of M2, which is connected by string. So the tension will be always opposite to at the point of contact is away from the point of contact. We call it tension. Now this is the applied force. So always tension is away from the point of contact, away from the point of contact. So we call it tensional force. Tension, that means tension is nothing but right. Tension is always act away from the point of contact in the strings. Tension is always acts. Will please write. Tension is always acts away from the point of contact in the strings. In the strings. So we'll write tension and force and same units and same dimensions. So T here also can put a T. That is T is equal to F here. Next. Next. Thrust. Thrust. Thrust or upthrust. Upthrust force. Upthrust force. Right. So where it is generally, if you take a liquid or fluids, now it is a fluid, then you are seeing up to here is a, I say water. Now I am trying to push the ball. As I am trying to push the ball, the upward forces are acting with what? Upward thrust is acting opposite direction. This is the upward force called thrust. In generally fluids we are going to use. It is called thrust. It is called thrust. Upthrust or thrust force. So both are same. Thrust or upthrust is the same this one. Now write note. We'll write NOTE note. Write note. Force, comma, force, comma, force, comma, tension, force, comma, tension, comma, thrust, thrust. All are having same dimensional formula, same dimensional formula, and units, okay na? Okay.
Sir.